Linear changes of scale and origin. The situation is exactly the same as it was for discrete random variables, in that changes of origin, that means adding a fixed number to the domain, affects only the expected value, but changes of scale, multiplying the domain by a fixed number, affects both expected value and variance. This is illustrated in the diagrams below using a uniform continuous distribution, but the principle is the same for any type of distribution. So if we consider this uniform distribution between 2 and 8, we can see that the expected value would be 5, and we can see that from the symmetry. And for this particular one, the variance is equal to 3. Now, if we consider just moving it along, and we can see compared to this that we've just moved along by 3 units, that does affect the expectation. But it doesn't affect the variance. The dispersion of this is exactly the same. On the other hand, if we just multiply all of the x values by 2, that affects the expectation. We can see it's doubled from 5 to 10. But it also affects the variance. The data is now more spread out. The 12 comes from 4 times 3. We know that we multiplied all of the x values by 2. The 4 is 2 squared. So that's 2 squared times 3. This is exactly the same findings that we had when we looked at discrete random variables. The point is that just moving the distribution left or right affects where the center is, but not how spread out it is. Dilating the distribution, that means multiplying all the x values by a value, affects both, unless the center was at the origin. If the center was at the origin, it will stay at the origin. Suppose we have a continuous random variable x and a continuous random variable y defined as y is equal to ax plus b. Then the expectation of y is a times the expectation of x plus b. So we see the expectation being affected both by multiplying and by adding. The variance of y is a squared times the variance of x. Remember, variance is a squared unit. The b plays no part because just moving does not affect the spread. The standard deviation of y is then a times the standard deviation of x.